Okay, today we're going to graph square and cube roots. Fortunately, this is something that you have already done. We're only going to add one little twist to it. But you remember that we have graphed both cube roots and square roots and transformed them. Now, part of the book is going to show that if you wanted to say graph the square root of x or some square or cube root, that you make a table. And you could put any value in. Like if I put a 3 in for x, I would get something that comes out. I'd have to use my calculator to do that. And you could graph it that way. We are not going to, right? I know you can put numbers in a calculator. I know you can make an XY chart. I know you can graph them. So we are going to use the transformation method like we've done before. So remember that what we're going to do when we do the transformation method is we are going to plot the parent graphs, and then we are going to shift them and stretch them. So the first thing we have to review is how do we make the parent graphs for the square root. Remember, no negatives under the square root, so I cannot have a negative value for x, but I could have 0. So we'll start the parent table at 0, and then we'll cover all the perfect squares that'll fit on the graph. So 1's a perfect square, 4 is a perfect square, 9's a perfect square. So 0, 1, 4, 9 are my x values, and the y values that I get out would be 1, 0, 1, 2, and 3. So that would be my parent table. I'd then plot that. So that's what your parent graph and your parent table will always look like that. You're always going to use those points. And the way I showed you to do it is we're not actually going to make you plot the parent graph, but you need to have the parent table, okay? Let's look at the cube root. Now we could have a negative underneath the cube root sign, so I could put a negative 8 underneath the cube root. I'd get a negative 2 out. So what I'm going to do is use my perfect cubes. So 8's a perfect cube, so I'm going to have a negative 8, a negative 1, 0, 1, and 8. Those are my perfect cubes, so if I put those under a cube root, for a negative 8, I'd get a negative 2 out. For negative 1, I'd get a negative 1 out. 0, I get 0. 1, I get 1. 8, I get 2. Those are going to be the values you use. Okay, let's look at the domain and range of these two graphs. Now look at the square root, because I cannot put any negative value underneath the square root. That's going to mean that as soon as I get to 0, putting in a 0 in the parent, y equals x squared, it's just going to stop. I can't put in any negative number. And because I can't put a negative number in for x, I'm not going to get a negative number out for y. So what we see is the square root graph actually just comes along and stops at 0, 0. That's going to mean the domain is going to be x is greater or equal to 0. And in interval notation, of course, we write it like that. And for y, the range is going to be greater than or equal to 0, and there's the interval notation. Now for the cube root, because I can put a negative underneath the cube root sign, I'm not going to have any domain limitations. I could put any number in there because I can put a negative underneath this cube root. So you can see that the arrows go out forever left and right, and they will go up forever. So the domain is x equal to all reals, and the range is y equal to all reals. Okay, so let's go on now and talk about the transformations. Now, we are going to add one little piece of complexity that we haven't done before. Before, we did have an x shift and an x stretch, but we never really combined the two at the same time. So look underneath here, I've got a c value, which would be an x stretch or shrink, and I have an h value, which would be an x shift. And I have both of those going on at the same time in these problems. Okay, so let's kind of review what we have. The a value, that a value is going to be a y stretch or shrink, which means it's going to be a vertical stretch or shrink, right? Y moves up and down. So that would be a vertical stretch or shrink. If there's a negative in front of the a, then that would be a reflection across the x-axis. It would flip the y value, would take a y value that would be up here, and it would move it across because it would be negative. So if there's a negative in front of the a, it's going to reflect across the x-axis. Now remember the c value, that's going to be the x stretch or shrink. So it's going to be a stretch or shrink horizontally. And remember what we do with c is the actual thing we're going to multiply the x by is 1 over c, the reciprocal. So that's a really key that whatever c is, when we multiply that by x, it's going to be the reciprocal of c. Okay? And what we have is, remember, h is always going to be the opposite sign because it says x minus h. That's going to be the x shift, which would be the horizontal shift. And the k value is going to be the y shift, which would be a vertical shift, up and down. Okay, so let's move on now and take a little bit closer look at this c value and how it affects x. Okay, and the way I do this is, since we have not combined an x stretch and an x shift before, we need to have a technique that we're going to use. And what you need to do is you actually need to factor the c out, and I'm going to show you how to do this in the bottom 2 examples. So let's take a look at the first example here. And what we have is we have y is equal to 3x. So since c is equal to 3, what I'm actually going to multiply the x by is 1/3. I take the reciprocal. So what this is going to be, it's going to be a horizontal shrink by a factor of 1/3. Remember, x is a horizontal movement, and since I'm taking it by a fraction, it's going to be a shrink. Let's go down to the next example. And we see that y is equal to x over 2. So my c value in here is actually equal to 1/2. Remember, we multiply x by the reciprocal of c. So what I'm actually going to do when I make my shifted and stretch table is I'm going to multiply x by 2. And since x is a horizontal movement, I am going to actually stretch x by a factor of 2. It's a stretch because that 2 is not a fraction. Okay, now let's come down and look at a combination of both x stretches and shifts. Now what we have to do here is we're going to be real consistent about this. There's several different ways to do this, and the way I'm going to show you is we want to factor whatever value is in front of the x out. So if I pull a 2 out right here, pulling that 2 out, this is going to be 2 times x minus 3. And if I want to do my stretch or my shrink first, which is the way I want you to do it, you have to factor that c out. So now what we see is once I factor the c out, what that leaves me with is x minus 3. So my actual h value is equal to 3. Okay, so that's what you need to do. Factor that c out. So what we found out now is that c is equal to 2. Which means I'm actually going to multiply the x value by 1/2. That's an x shrink by 1/2, a horizontal shrink by 1/2, and its h is 3, so after I shrink it, it's going to move to the right by 3, okay? So this would be the actual shift to the right. You shrink it first by pulling that c off, okay? Let's take a look at the next one. Now what I see is that I have both an x shift right here, and I also have an x stretch or shrink. So let's pull the whole value that's multiplying the x off. That's a negative 1/2. So if I pull the negative 1/2 off the x, I have to factor it off the negative 3 also. And what I would get is I'd get a negative 1/2 times x plus 6. So what we see here is that the c value is actually equal to a negative 1/2, which means that I'm going to reflect it over the y-axis, and what I'm going to multiply it by, c is negative 1/2, so I'm going to multiply x by negative 2. So what I'm actually going to do is stretch it by 2. It's going to be a horizontal stretch of 2, and the reflection across the y-axis because it's got this negative. All right. Then after I do that, we can see that the h value is actually equal to a -6. So this thing would actually move to the left by 6, right? This would be 6 left. Okay. And that's how we'll transform that. Now when we do the tables, we're actually just going to shift everything in the tables. So, well, the next thing is a summary table. This is in the book, so I'm not going to take the time to have you copy it down. You can copy it out of the book if you want to leave a space. I just got that right out of the book. It summarizes everything, but I'd like to move right on to work on a couple examples now. Okay, so if you need to copy that out of the book, go ahead. So let's take a look at the first problem. What I have is I have a function of x is equal to 1/4, f of x is equal to 1/4 x. So the first thing I'm going to do is find out what a is equal to. All right, that would be the number that's multiplied outside the square root sign. You can see it's 1. So my y, stretch or shrink, is just 1. For the x, what I have here is you can see that the c value is equal to 1/4. So what I'm actually going to multiply the x by is the reciprocal of that. So I'm actually going to multiply x by 4 when I actually make my table. There is no h and no k. There's no shift added or subtracted. So let's go ahead and work with this. So what we've already said is there's no shifts going on. So what I do first is I make my parent graph. This will always be the same, or my parent table, I'm not actually going to graph it. The parent table is simply y is equal to the square root of x, and I fill in my values 0, 1, 4, and 9 for x and get my y values out. And then I'm going to take that table and I'm going to shift it or stretch it. And all we had going on here is we had the c value was a negative, c value was 1/4, which I stated earlier means I'm going to take times the reciprocal, which is 4, so it's 4 times x. So every x value in this table would multiply by 4, and the y's don't change at all. So 0, 0 would still be 0, 0. This would be 1 for the x. 1 times 4 is 4. The y value stays the same. So I took all my x values, multiplied them by 4, and you can see the y values stayed the same. There's nothing happening to y, and I plotted those over here, and that would be my final graph that has the stretches taken into account. Okay, the next example is a pretty simple cube root. Let's look and see what's going on. For one, let's look and see if there's an a value, and there is. A is equal to a -3. That means that this graph is going to be reflected across the x-axis. So for whatever y value I have, if it's up here, the negative would reflect that across. And we can see that the a value is also a -3, so what we're going to have is we're going to have the y value is going to stretch by a factor of 3, which is a vertical stretch by a factor of 3. I don't have anything else going on. C is 1, right? There's a 1 in front of the x, and the h and k's are 0, so the only thing I have going on is that y stretch. So what I'll do is I'll make my parent cube root table, right? So here are my parent values, a -8, -1, 0, 1, and 8 for x, and then I can figure out my y's are. Then we'll do the same thing all the time for a cube root. And then what I'm going to do is there are no changes in the x, but the y is going to multiply by the a value, so it's a -3 times y. So every single one of my y values, a -2, will multiply by a -3, giving me 6. 1 would multiply by a -3, giving me a -1 multiplies by a -3, giving me 3. 0 multiplies by -3, giving me 0, so on and so forth. So here is my shifted table, and that's what I plot. And you can see that compared to the original cube root graph, kind of looks like this, that it's reflected and stretched. Okay, so let's do one quick example here. I have the graph of f of x is equal to x over 3. That's a square root. And so what my a value is that be the what's multiplied outside the square root. That's simply 1. For my c value is 1/3. So that means I'm going to multiply x by a factor of 3. Okay, that is going to be a horizontal stretch by a factor of 3. Okay, I don't have any h or k. They're 0. So I don't need to worry about those. So 0 and 0. So let's fill out the parent table for a square root. 0, 1, 4, 9, and the square root of 0 is 0. Square root of 1 is 1. 2, square root of 9 is 3. And now let's make the shifted table. So the only thing I have going on here is I'm going to multiply x by a factor of 3. Okay, so I'm going to have 3x, y stays the same. So 0 times 0 is 0. 1 times 3 is 3, 1. 4 over here for the x. 4 times 3 is 12, and my y value is 2. And 9 times 3 is 27. My y value is 3. So plotting that, I have 0, 0. I have 3, 1. And I have 12, 2. And that would be my graph. My domain is going to be all x values greater than or equal to 0. And the y values are also all values greater than or equal to 0, right? The closed bracket means equal to. Okay? In this next example, what it says is we're going to describe the transformation and we have to graph it. So what we see is we're starting with the square root of x and we're moving to this g of x, so it's transformed. Notice that there's nothing multiplied outside of the square root, so a is equal to 1. There are no y stretch or shrink. Okay, the c value that's in front of the x is also equal to 1, so there's no x stretch or shrink. Remember, the y stretch is vertical, the x stretch or shrink is horizontal. And now let's see what's happening. We have h is actually equal to 3, so this is going to be a shift right by 3 units, and the k value is 4. That's a shift up 4 units. Okay, so let's quickly make the table and shift it. So this is the parent. So I've got 0, 1, 4, and 9, which is going to give me 0, 1, 2, 3. Actually, I guess I should check to make sure this was a square root. It is a square root. And so then what's going to happen is it's going to be x, where's my h? X plus 3 and y plus 4. So we're going to go ahead and x plus 3 would be 3, 4. 1 plus 3 is 4, 5. 4 plus 3 is 7. 2 plus 4 is 6. 9 plus 3 is 12. 7.
Good morning, Washington High School. Attention men of Washington High School.
Okay, now that we have the table, let's go ahead and plot it. So I'm going to have 3, 4. 4, 5. 7, 6, and 12, 7. That's going to be my graph, and let's go ahead and get the domain and range. So the domain is going to be related to the h value, which is the x, and the range is going to be related to the k value, which is y. So we have the domain. We're going to have x is greater than or equal to 3, which in interval notation would look like that. The range would be y is greater than or equal to 4, which in interval notation would look like that. Okay, so let's go down to a different kind of problem. Okay, now what in this example, what they're doing is they're saying, okay, we're starting with a graph f of x equals to the cube root of x, and then we're going to transform that graph by shrinking by a factor of 1/6 horizontally. So I'm shrinking by a factor of 1/6 horizontally, and I'm following that by a translation 3 units to the left, and that's going to give me a new graph, a new function g. And so I need to write the equation for g of x. Okay, so let's figure out what's going on. I have a horizontal shrink by a factor of 1/6. So horizontal, that's going to be x. And if it's a horizontal shrink by a factor of 1/6, the c, the value that the c would actually be the reciprocal of that. So c would be equal to 6. Now it's also going to be shifted 3 units to the left. So to the left, that's a horizontal shift. And so that what that tells me is it's going to the left. So h is going to be equal to a -3. So h is equal to a -3. Okay, so our new function, that's all we have going on, is going to be the cube root. And we said that the multiplier c is 6. And what we would have is we would then have x minus h. So x minus a -3 would be x plus 3. So that would be my equation. And when I multiply that out, I would get 6x plus 18. Let's work another example. Okay, so for this one, what we have a horizontal stretch by a factor of 3. So what that's going to be, a horizontal stretch by a factor of 3. So the reciprocal of that, so first horizontal, of course, that's x. We know that x will use the reciprocal of whatever the stretch is, c. So if the horizontal stretch is 3, then c must be equal to 1/3. And then it's going to translate to the right by translate 6 units to the right. So that's telling me h is 6. Okay, so let's put that into the equation. So I have g of x is equal to 1/3 times x minus 6, x minus h, which would be equal to x all over 3 minus 2. And I forgot my cube root. Let's make sure I put those on the previous example too. Yep, got them there. That's it.